Okay, good afternoon, everyone. Welcome to the session 5 of 3 days international workshop on sports biomechanics organized by Degree College of Physical Education, Amravati. Here, with on the offline mode, we have workshop director Dr. Madhuri Chenke ma'am. We have organizing secretary Dr. L.M. Khandagale sir, convener of the workshop Dr. Anita Gupta ma'am, and also as an anchor Mr. Mayur sir. Now, I request Assistant Professor Mayur Kumar sir to introduce our today's resource person. Mayur sir. Thank you so much, Mayur sir. Now I request Praveen sir to please start his presentation.
I thank everyone for giving me an opportunity to present my lecture. Uh, Today's lecture will be on the introduction to 2D motion analysis, in which uh, I'll be demonstrating as well as using the software Kinovia. And the second part of the lecture focuses on the use of force plate in sports science. So, if time permits, I will try to demonstrate that also, what kind of curve we get and how we can interpret and how we can use it. So now I'm sharing my screen. Please let me know if it is visible. Uh, is my screen visible?
Yes, sir.
Yeah. The first part of Uh, today's lecture is Introduction to 2D Motion Analysis. I know many of you might be using certain softwares to calculate or to calculate certain kinematic parameters or to do qualitative motion analysis also. So I will just give you an overview of this introduction. What are the tools required? What are the minimum tools required? Because we all know that for motion analysis, 3D motion capture is termed as gold standard, but everybody uh, does not have the resources to buy the 3D motion analysis, which may run into crores of rupees. And by 3D motion, I mean like set of more than 5 cameras, biomechanical software, and other accessories. So the focus of this lecture would be like using minimum tools, minimum cameras, how we can set up the camera and how we can use for biomechanical analysis. So that forms the crux of the first part of the lecture. Now, why do we use 2D motion analysis? As I've already said that it can be used to analyze any movement, and it can be used to qualitatively as well as quantitatively specify the kinematics, especially the kinematics. So using the 2D motion analysis, we can actually do sports specific movements or exercise movements also. We can cover the exercise movements also, and we can actually see the qualitative part where wherever the player is feeling more stress. For example, we can actually analyze when a player is jumping and when a player is landing. We can actually analyze the correctness of that movement, the correctness of the landing mechanics. We can assess qualitatively, and quantitatively we can actually find out the speed of that particular movement, and using that particular movement parameter we can actually calculate the other parameters also. And as you know, this is the most affordable means. Like today's in today's world, you have iPhones, you have Android phones, and you might find a simple smartphone that may reach up to 30 frames per second, and iPhone obviously can reach up to 240 frames per second. But today some Android phones also reaching that capacity, also more than 200. You may must have observed the slow mo capture feature. Okay, so now the minimum requirement is you have to have adequate lighting. If you are doing it outdoors, particularly in the noon time or afternoon, then sufficient lighting is available. If you are going towards the dawn, towards the evening, then sufficient lighting is required. If you are uh, doing some analysis in lab, then also sufficient lighting is required. So normal typical lighting is like 500 to 1000 lumens. So based on that, basically you have to adjust certain camera features. Okay. So and then you need a space, especially for if you are doing it indoors, so that that particular action can be performed without any hindrance. Then you need video camera having sufficient frame rate, sufficient shutter speed, sufficient resolution. Then laptop, TV screen to either you can display it live, or after you have captured, you can analyze the same video in the laptop. And how will you analyze it? You will use a video analysis software. Now there are different bunch of software, different types of software which is available in the market. There are certain free version also, there are certain paid version also. So in this lecture I will be demonstrating the uh, use of Kinovia software. Okay, so but first of all, like we need to understand what are the limitations of 2D analysis and how to maximize uh, the parameters which you want to get from the 2D motion analysis. So why I am saying that? Because 2D motion analysis is limited to certain aspects only. Because, for example, plane of motion, we have to restrict the 2D motion up to the plane of motion. If anything goes outside the plane of motion, then your reading might have exaggerated values. So we want to avoid those situations. Okay. So this is a typical setup of a 2D motion capture. Here, suppose an athlete is running. So I have placed minimum requirement of 3 cameras. Actually, you can have more, also depending upon the segment you want to cover. So most of the time, if you want to have a sagittal view, or which is known as the side view also, the camera should be placed like this. The optical axis of the camera should be perpendicular to the plane of motion of that particular athlete. This is the first requirement. And then if you want to see the alignment, body alignment from front, how the left and right extremities are moving with respect to the motion, whether it is out of alignment, whether the player is going too much in the frontal plane, too much movements are happening in the frontal planes or not, we can actually analyze with the help of front camera and back camera. Then these days, you might have seen that several competitions are being held and they are being covered with the help of drone cameras. So which actually gives you bird's view. But again, like the cost factor comes into the picture. So this is a minimum required. But even with single one side view, if you have one camera, you can actually find out many factors. And then all this data is fed into the laptop, and the laptop actually contains the video analysis software. So if you have paid version, there is a version, there is a mode called live version with a delay. That means suppose a player has performed, suppose I'm talking about a judo player or a taekwondo player. I want to see, I want to show the player how effective his kick was, what was the technique. I want to show the technique to the player qualitatively. So there is a feature that you can actually take the video while performing the action, and then you can uh, take the video which is connected through a wire through a laptop or a big screen, and after a 10-second delay the player performs his action and comes to you, and you can show him or her the action, what are the deficiencies in the action and how the movement is correct. Okay, like these kind of things. So this is the minimum requirement. And how to set up a camera? As I said, if you are analyzing a side view, so basically a simple Pythagoras theorem is followed to make sure that optical axis is perpendicular to the plane of motion. Okay, so you can see, like suppose this is the plane of motion. You can actually measure, suppose let's say I measure 3 meters, and then the straight line almost perpendicular to it, I will measure it 4 meters. Okay, so using Pythagoras, suppose this is the end point, and from this point to the starting point of this distance, if the distance is 5 meters, then I would say like my camera setup is successful. My optical axis is perpendicular to the optical axis of camera is perpendicular to the plane of motion of the plane of motion of that particular plane. Okay, so this is a typical setup, and based on this, uh, you can then you can either you can move the camera nearer to the athlete or further away from the athlete. If you, it depends how much area you want to cover, how much area you want to cover. Okay, so this is the minimum requirement, and using a simple tape you can do that. And depending upon the height of the camera, usually it is kept at hip width, hip height. Okay, but again you have to see where is the point of focus. If your point of focus should be exactly in the middle of the screen, and you have to find out the certain height which actually allows you to do that. Okay, so here are certain errors which you may encounter if your plane of motion, if you're performing your action out of the plane of motion of the calibrated zone. Okay, so these errors are called perspective errors. So here you can see this is the intended plane of motion. I want to measure this athlete's height in this plane of motion, but the athlete is standing outside the plane of motion. Now, why I am saying that? Because I will have certain reference point. Suppose this is a 1 meter stick. I will have a reference, certain reference point, 1 meter stick in the same plane of motion. So if the player stands in the same line, same plane of motion, then only I will be getting the accurate readings, accurate height. If the player stands a step further, its height would appear to be decreased because my reference point is out of the plane of the motion. If the player stands behind that plane, his height would be exaggerated. Why? Because this and this, these are out of plane. Okay, so this is called perspective error. And if you want to cover wide area and if you want to reduce the perspective error, usually it is done by placing the camera far away. Okay, now in this kind of situations, angles are not affected. Angles are not affected, but uh, you will underestimate the angle or over exaggerate the angle also if your plane of motion, particularly if you are measuring any joint angle, and that particular motion actually goes out of the plane of motion. Okay, like we'll be able to see in this example. For example, this is a rotational error which we may find in cameras also. So we have to take care of these things also. So for example, I will give you a simple example. So I have fixed, suppose I have fixed my elbow at 90 degrees of angle like this. Okay, now from this position, you might be saying that okay, this is 90 degrees. Now this is parallel to the plane. You know, the movement, whatever, if I'm doing elbow flexion, it is parallel to the plane, and the plane is perpendicular to the camera. So I will be able to uh, accurately quantify it is 90 degrees. But keeping my elbows locked, rotate, if I rotate my shoulder like this, now the angle is still 90. But if you measure using software, it will show different angle. Similarly, if I rotate it outwards, angle is still 90. I know that. But if you use video camera, it may exaggerate or underestimate that. So these are the things which we need to take care of. Then the camera selection. Now, I will be, there are many things in while selecting camera because we are discussing the basics. So I will be keeping the things very simple here. So what frame rate to select and what is frame rate, what is shutter speed. So first of all, I will discuss the frame rate. Frame rates means how much data is collected per second by the camera, or simply said, how many frames can you see per second. The selection of frame rate actually depends upon the speed of movement. Okay, so you can actually, there is a formula actually. If you can actually divide the object velocity by the frame rate, divide the object velocity by the frame rate, you will actually get some distance. Okay, that distance is per frame, how much uh, distance your object has moved. That means that if the object has moved minimum distance, that means you are not losing information. So as speed of motion increases, your frame rate has to increase. So for example, if I have to analyze a badminton smash, if I select 100 frame rates, I may not be able to measure. I need at least 1000 frame rates. So in a simple word, this figure actually depicts the differentiation between lower frame rates and the higher frame rates. Like in this figure, it is depicted 1 frame rate, 10 frame rates, and 30 frame rates. You can see that if I use 1 frame rates per second camera, okay, at particular instant, I cannot, I can see this car, but by the time I go to the next frame, जैसे ही मैं next frame में जाता हूँ, like you will see that the car is far away. So this is the information I am losing. Okay, now you further increase the frame rate. Now you will see some of information has appeared because you have increased the frame rate. And if you further increase the frame rate, you will see that at each instance of time, you will find the image of the car. It is similar to, like, for example, if I'm kicking a football, suppose this is a football, I am kicking a football. Now I want to analyze the kick, especially what my foot is doing to the football. So if I use low frame rate camera, if I try to capture it, so in one frame rate, I might find my foot is about to touch the ball, and in next frame, if the frame rate is very low, the football has is out of the frame. You cannot see. Okay, it is out of the frame. Okay, so now in this instance, if I increase the frame rate, so I can actually find out step by step information of my kick. Even I can find out the amount of time for during which I have made contact with this ball. मैंने कितनी देर बॉल के साथ कांटेक्ट किया, like you can find out using that. So this is frame rate. So typically, 100 frame rates is okay. You can, if you have 100 frame rates camera, it is good enough to capture a sprint. अगर आपको sprint capture करना है, it is good enough. But as soon as the speed of movement or speed of implement increases, you have to increase the frame rate. That way, you will be safe. So same way you can see in this figure also, a 60 frame rate and 120 frame rates. So per frame actually you are able to see the path of the ball clearly if you have higher frame rate. Okay. Now higher frame rate comes with a price also. Okay, it has a direct you can say relation with the shutter speed. Shutter speed is the amount of time your camera is exposed to the light. So the rule of the thumb says normally what is the criteria? They say that the shutter speed should be double of the frame rate. Suppose if my frame rate is 100 frames per second, so my shutter speed will be double of 100, 200, reciprocal of that 200, 1 by 200. Okay, that is the thing. So that means the amount of time for which the camera is open to allow the light. So faster shutter speed basically provide you sharp images, and slower shutter speed basically provide you motion blurred images. Okay, so motion blurred, you can say that you can actually find out the smudge around this image, as you can see the smudge around this image. Okay, and the motion, there is a formula for that also. Like if you have to calculate the motion blur, it is dependent upon the object velocity. You just multiply it with if you multiply the object velocity by shutter speed, you will actually get the distance of that motion blur. So this should be minimum, this should be low only. So depending upon that, you will find the appropriate shutter speed also. But the rule of the thumb says, like if you select higher frame rate, you double the shutter speed, inverse of the shutter speed. Okay, like uh, as you can see in these images. Okay, but here is a catch. If you increase the shutter speed, that means the shutter is open for a very small time. That means uh, your lighting has to be proper. If you're measuring that, your lighting has to be proper. Okay, so that is one of the things which you have to sacrifice. That means you have to choose a place where you want to use the high frame rate as well as the shutter speed also. Okay, and also with higher frame rates, you will find that as you go higher with the frame rate, the resolution takes a beating. Resolution decreases. Okay, that also you have to take into account. So for ideally, for a sprint, 100 meters is enough. If you have more, as I said, more is the merrier. Okay, more the merrier. Now, coming to the video analysis software part. So, this is a freely available software, Kinovia. I believe everybody is using it. Uh, can I get some answers? Like, I just want to know whether you are aware of
Yes,
this
sir.
software. Yeah,
Actually, there is one course over here running, DSP, a Diploma in Sport Performance Analysis, and they use this software, sir.
yeah. So that's fine. That's good. So we also use this software. Apart from this, there's Silicon Pro Coach software, Dartfish, and Max Pro Tool. Now these all are paid softwares, and if you ask me the price, now these days they don't give lifetime softwares. ये आपको lifetime software नहीं देते हैं. So Dartfish is approximately 1.5 lakhs per year. But Dartfish has many modes. It has performance analysis mode also. ठीक है, it has many modes also. बहुत तरीके के इसके modes हैं. Depending upon that, the price will increase. So I have quoted what we have demanded from our center. So the beauty of Dartfish is like you can connect actually more than 4 cameras. I think, if I believe 5 cameras can be connected, and that data actually can be used for modeling studies if you are interested in that. Okay, and apart from this, Max Pro Tool and Silicon Pro Coach, these are all paid softwares. Again, Silicon Pro Coach is somewhere around 50 to 70,000 rupees. Max Pro Tool is also in the same range. Then, apart from Kinovia, we have uh, one more freely available software, which is Coach's Eye. That is also there. Okay, so I will just share some of the analysis which we have done. Then I will go to the practical part of that. Now, this is one of the analysis which we do. Now, here, this is, you can see, basically it is qualitative because there is no unit measure, but I will demonstrate it. Like, you already know how to do this. This is a typical analysis of weightlifting barbell trajectory. We can actually follow the pathway of the barbell trajectory of a weightlifter. Okay, and then this is an image which is taken from the web. We also do it uh, the same way, in which we can actually look at the alignment of a sprinter. So this also can be done by the Kinovia software, placing the camera at appropriate position. Now this is a typical volleyball analysis. So actually my Windows, my PowerPoint version is little bit on the lower side. It is pre 2010, 2007 version. So video, this actually is a video. It can be played, can't be played actually. So, but yeah, step by step you can do. This is a volleyball smash analysis. Okay. Okay, now this is a typical comparison of a taekwondo kick. Again, it is qualitative, where we have compared our in-house taekwondo player with this same kick has been compared with a foreign player. How to tell the player how stable that foreign player is. You can actually see the amount of lateral flexion, the lateral leaning, the comparison between the lateral leaning of the foreign player as well as in-house. And we can actually analyze different other sports like hockey also in here, uh, how the push we made. Okay, what is the position of the body, what is the position of the foot, we can actually tell it to the players. We can actually point their mistakes. Same way we can actually find out, like if you want to analyze a drag figure, what is his uh, front foot doing, in which direction the front foot is. So these are the small things which can be found out by using this. So yeah, this is an image of a para athlete. I was fortunate enough to work with these athletes. As you can see, we have found out the height of release and the distance of that disc from the stationary point. Okay, this distance, I'm talking about this distance. Okay, we have found out that also, and we actually can find out the angle also. Okay, so before I go into the next section, I will just show you some videos of certain some analysis which we have done with our national campus as well as in-house NCOE players. So please tell me if you are able to see that screen. I'm going to share the. Okay, is the screen visible? It's okay.
Yes, sir.
Yeah. So now this analysis has been done using Kinovia software only, and as you can see in Kinovia software we have various modes, various buttons, as you can say, the digital buttons using which we can I can select the stopwatch, I can select the vertical line, I can basically select the kinematic parameters which I want to measure. Okay, so again, I'm using weightlifter as a reference here. So this is a weightlifter. Okay, so the weight is insignificant. The point of our discussion is the analysis part. As you can see, this is a composite video using the software Kinovia. As you can see, we have divided the weightlifting into different phases. As you can see, the first pull, the timer for first pull is there, and then the transition phase is the phase where actually there is a slight flexion at the knee, slight dorsiflexion at the ankle. Okay, and then the second pull, we have actually measured that second pull also, and then you can see when the player is underneath the bar, we can actually see the catch phase, and from that end of the catch phase we will find that we have you can see that we have calculated that lift phase also. Now the timings, as you can see, the timings, this the accuracy of this timing will depend upon the frame rate of your camera. So this is a very a tricky thing if you use lower frame rate, because this weightlifting is a high speed. In a single push, like it's over, it does not it is below 5 seconds. Okay, so you have to use appropriate camera for the same. Okay, so same can be done using the Kinova software. This is, yes, the lift phase, as you can see, and here you can see the barbell trajectory also. Barbell trajectory also. So, and from the same Kinovia, actually uh, you can actually get kinematic data also. So I will try to share that also. Okay, like this is the barbell trajectory velocity, and you can actually see that the various phases, frame by frame, you can find out this is actually the transition phase. As you can see, there's a slight dip. The dip should be minimum. In fact, you can find out that yourself if you do that. So the first pull, the transition phase, the second pull velocity, you can actually see the difference. So using this, we can actually find out and give information to the coach that, like, whether the player is spending too much time in the transition, is there too much drop in the velocity of the transition, Okay, these small things we can convey to the coach, and they can start working on that. That may be because of some muscular strength issue. For example, the transition phase relies on the eccentric strength. Okay, the body is going down with the gravity. You have to control that. The eccentric strength training matters in this regard. So you can actually find out small things from these analysis. Then, so yeah, this is analyzed video of a race walker again using the same Kinovia software. As you can see, we have found out the flight time, we have found out the contact time, we have found out the step ratio itself. As you can see, uh, once again I will play it again. Okay, okay, I'm not able to stop it. uh, Okay, so we can actually find out the step ratio. We can find out the step length ratio also. Step length ratio is normalized step length with the height, and we can actually find out how much percentage of the step is in the forward position. हम ये भी दिखा सकते हैं. So then we can compare it with the step length. That again is a step ratio. We call it step ratio also. So these are the things again using the Kinovia software, and you can see the speed of this person also, speed of this athlete also. So in race walking, as you can see, like flight time has to be minimized. Uh, it should be actually less than actually rule book says that there should be no flight time, but invariable research has found out that there is some amount of flight time which cannot be detected by naked eyes. So that is less, that should be less than zero point zero 0.04. If it is zero point zero 0.04, more than zero point zero 0.04 the contact time, then you will be able to detect that. So and then yeah, this is a national level shooter. We have done the shooting analysis. As you can see, there are some differences in the stance position. So, so we actually, the player is young, so we have not advised any change in the technique. Rather, we have advised certain strengthening program along with the SNC, strength and conditioning के साथ मिलके the athlete is working on uh, her posture. So,
Sir, you can click the hide button over there. Hide. Yes.
okay, yeah, thank you. Is the screen still visible? No? Yeah.
Yes, sir. Yes, sir.
Okay. Now, now using this Kinovia software, actually, there are certain applications which are available in the market also, which are available in the Android also. There are certain applications like My Jump app. You must have heard about that. Then there is a My Sprint app also. You must have heard about that. So basically, if you can measure, suppose I'm talking about sprint, if you can measure like segments different segments of a sprint. Suppose I'm trying to measure the acceleration, how the player is faring in the acceleration of a 100-meter sprinter. So I will ask him or her to run through a 40-meter distance, 40 or 50-meter distance, and I will place exactly cones at every 10 meters. So based on that, you if you place the camera in appropriate position with minimum equipment, you will be able to find out the split times. And using that split time, actually, you can find out uh, various things. So suppose this is a sample I have prepared, you can actually see the segmental velocity, segmental acceleration. Now, these are the time, actually we have used timing gates, but if somebody does not have timing gates, they can use cameras, and they can try to measure the split times, and based on that, uh, you can see we can find out the segmental velocity, segmental acceleration also. And using this data, you can actually create a force profile, horizontal force profile, using a mathematical model. Using a mathematical model. So that also you can do. Basically, you can find out the rate of decrement of ratio of horizontal force to the vertical force, or the total ground reaction force. You can actually use a mathematical model for that. So I'm not discussing that here, but uh, the things which you can find out using this 2D motion analysis can be used further for finding out the mechanical effectiveness of a sprint that you can use. So this is one of the sample, and yeah. So I will just open the Kinovia software. So so majority of you already know how to operate it. So I will be quick and brief in that. So this is the latest version of the software, and here I will just go to the my folders. I will just go to the open video. Yeah, I will try to open one of the video here. This is our NCOE player. So all of you know that like we can actually lock the working area of this software. Suppose I play this video. So I'm playing this. From the start of the lift, I can actually go back to toward, sorry, once again, and my mistake. So I can lock this area. Then I can close this area. I'll basically lock this so that only this area is played again and again. So you already know about this. So I'm using certain tools which is available here. So I won't be going that much into. So suppose if I want to measure the barbell trajectory, so you can actually uh, place a marker at the center of the barbells. Suppose my wish is to track the path, so I will place this at the center. I will just configure it. I will change the color so that it is visible to all. I will change the position like this, and then I will change the measurement. I would just want to know the speed. I'm interested in speed. Right now it will come in pixels because I have not calibrated it. Okay, then frame by frame you can see it is moving, and whenever it ends, suppose it ends here, I will just end path addition. Okay, so this is the barbell trajectory, and you can actually draw a vertical line here. uh, so you can actually draw some vertical line. If you want some reference point, you can actually place the line here. Okay, again it is coming in pixels because I'm not calibrated. So suppose ki, I want to calibrate it. I take okay, I will once again do the line. Suppose I know this distance. Suppose this is the distance I know, this is 18. I will right click, go to calibrate, then I will say 18 centimeters roughly, let's say. So based on that you will see uh, the distance has come. Okay, Okay, based on that, it will calculate other parameters. Okay, so again, it has a feature on stopwatch also. You can actually see if I right click, uh, I'll just so I can start the stopwatch whenever I want, which whichever phase I want to measure. Suppose I want to measure the first full, so I will place the stopwatch. I will label the stopwatch as first full as I've shown in the videos, and then you can actually work on that. So this is yeah, simple demonstration of Kinevere software. So are there any questions regarding this? Uh, then I will move on to the next topic.
Sir, let me ask to the participants, is there any questions? So there is one question actually.
Yeah, please.
Hello, sir. Sir,
Yeah,
actually, this
please.
is not question. I'm
Hmm.
just clearing it out.
Hmm.
अगर suppose my camera frame is 25 frame per second,
Hmm.
okay.
Hmm.
Then I am smashing up shuttle in badminton.
हाँ
तो
हाँ,
अगर
yes.
मेरे को ये अपने
Yeah.
स्पीड पता करना है अपने आर्म का,
Yeah, yes, yes,
तो
yes,
देयर इज अ
yes, yes,
फॉर्मूला
yes. Yeah,
डिस्टेंस
that's
अपॉन
why.
टाइम.
Yeah, वो
यस.
मैं अभी
तो
क्लियर करता हूँ. I will
तो
just clear.
टाइम
See,
निकालने के लिए. यस. ओके.
yeah, I will just clarify. If you want to measure the speed of the shuttle, now the speed of the shuttle is far as compared to your frame rate. Okay, in order to accurately predict the speed or find out the speed, you increase the frame rate of that camera. Okay, so badminton I have clarified. See, there's a very simple formula, like you can actually divide uh, the object velocity with the frame rate. So in badminton, like the shuttle speed can go up to 400 meters. 400, am I right?
Yes, 480
International,
was, yes.
है ना?
450
So
also.
based on
450
that,
also.
yeah, if you want to track, if you want to, yeah, accurately predict that, so it depends on the as I mentioned earlier, it depends on the speed of the speed of the implement, speed of the movement, or speed of the object. So you need to have higher frame rate camera, 1000 frame rate camera. So right now, actually, in our lab, we have procured one camera on Sony FDR AX700. It can go up to 1000 frame rates also, but the time duration will be very less. So, but it will be very helpful for you. So you increase the frame rate, you adjust the shutter speed, as I've mentioned before. So shutter speed also has to be adjusted. Otherwise, you will get blurry images.
1
So
by 2.
yeah.
Okay, sir.
So
Thank you.
depending upon the object's velocity, you adjust, you find out your frame rate. So actually, there is a publication. Uh, Title I don't remember. I will share. I will share the reference. I will share the reference in which uh, they have actually given what would be this according to the speed of the object. They have actually found out the appropriate frame rate, and the appropriate shutter speed also. So I will try to share that reference. Okay, so using that paper, you will you will clear many of your doubts regarding frame rate, regarding motion blur, even depth of field also. You will be clearing many doubts. Okay, so you need to use higher frame rates. So are there any questions, or like more
No, sir.
questions,
No,
or
sir. No, sir.
okay? So should
Sir,
I
there is
move
one
on?
more question, sir.
So
Sorry, sir.
yeah, yeah. So I'm moving to the second part of this presentation, which is use of force plates in sports science. I know that you must also be aware of this. You must have used this also, but again, I will be giving you an overview of this, and I will be I will try to perform a live demo of this. Okay. Now, use of force plate in sports science. So, what is a force plate and why it is useful? And these days, you must have seen whether it is a field of whether you talk about the field of strength and conditioning, whether you talk about the field of sports science, in clinical science also, physiotherapy also, you will see that like many hospitals, many sports science centers, and many big academies are also procuring force plate these days. Although again, it's a costly equipment, but it helps you find out your ground reaction force. Now, ground reaction force is nothing but like it is based on Newton's third law. It is just like you push the ground pushes you back, the same force, and it works on the same principle. And it presents a non-invasive and dynamic way to measure the ground reaction force. So I will be discussing the basics of force plate, uh, how to select an appropriate force plate, because there are many companies, and which sensor would you like. Okay, so I will be going through the basics. So now, why ground reaction force is important to us? Ground reaction force basically helps us in understanding the impact. It will help in understanding the impact. That means I'm talking about the impulse, force into time. Okay, the amount of force, the amount of time during which the force acts, the product of force and the amount of time during which the force acts, that is the impulse. It will help us in finding out that. And we know that in running, okay, and in swimming also we talk about impulses. In running we talk about the braking impulse, the propulsive impulse. Then the same ground reaction force is, if we can get a ground force and time curve, we can actually find out using an integral of that, to find out the velocity, the other kinematic parameters like velocity, the jump height, the power of an athlete. Okay, and the force plate actually can be used to assess the player, can be used to assess the player who is rehabilitating also. We can use the force plates in rehabilitation also. Okay, and there are many modalities which I will be going on to discuss. So there are different types of force plates available in market, uh, based on the transducer they use. Transducer is nothing but it's a material which actually converts one form of energy into the another form. So that means if you're talking about force plate, it is a transducer which converts your mechanical energy into electrical energy, which can be read through a software, and based on that we calculate certain parameters. So usually two kinds of transducers are available. Uh, Transducers are used in force plate. You must have heard about the strain gauge based and then the piezoelectric based. Okay, so both are unique for each and every person's requirement. So if you are measuring highly dynamic activities, like if you want to measure the impact of the landing, if you want to measure the takeoff force, okay, if you want to measure the lateral jump, so then you need a sensor that is highly dynamic, and it has a high sampling rate, and then it can convert that signal within a few microseconds into an electrical signal which can be read. If your requirement is low impact studies, like walking is considered low impact. Then standing, if you are measuring the balance, if you're doing postural studies, then you go for low impact, and then you go for strain gauge. Now the beauty of strain gauge is, because in balance studies the reading is taken for a very long time, minimum is 30 seconds, but you can go up to 3 minutes, 2 minutes, 3 minutes, 4 minutes, 5 minutes. In that period, strain gauge actually gives you a consistent pace of reading, okay, during that amount of duration. But piezoelectric, if you are trying to measure the activity during a very long period of time, then the reading may come down. Okay, so personally, like for highly dynamic activities, piezoelectric is the best. For certain dynamic activities, strain gauge is best. For balance based studies, long balance based studies, strain gauge, go for strain gauge. So there are many companies which are available in the market. Kistler is the only company which actually makes piezoelectric sensors, which makes force platform using piezoelectric sensors, piezoelectric transducers. Whereas sorry, other companies, like you might have heard about Force Dex, Force. Second. Sorry, there is some issue with my mouse actually. So okay, so so there are several companies like Force Dex, okay, which actually makes load cell based sensors and load cells based force plate, which are in the market. And then there is company called Bertec, Hawking Dynamics is there. So BTS also is there. But as I said, there are several companies. Even now, Indian companies also, like slowly they are coming up, because these all can be made in India also. And slowly, sports culture is also coming up in India. Sports science culture is also coming up in India because of the demand. And slowly we'll see in upcoming years, many like in 5 to 10 years, you will see like everybody like these force plates will be manufactured in India also. The cost will actually drastically reduce. Okay, so this is the hardware which I'm talking about. Then the software part. Software is the most tricky part, because Kistler actually gives you software which is free, BioWare, and there is a software for analysis which is MARS. The cost of this software is alone 9 lakhs, but whereas BioWare is freely available. The beauty of this Mars software is, and in Sai actually in our southern center, and as well as northern, as well as eastern center, we, we will be getting portable force plates. I hope by the end of this month we'll be getting that. Along with that, we'll be getting the Mars software also. So beauty of this software is like you just perform the test, and then you can generate the report instantly. All the things can be calculated by the software itself. But whereas in BioWare, with BioWare, with, you can also find out certain parameters, but certain calculations you have to do from your side to find out. Okay, it also gives, but it takes certain amount of time, because when I'm using BioWare, I'm finding out the phases of, suppose I'm talking about counter movement jump in my own way. Okay, so I have to segregate the different phases of counter movement jump in BioWare, but in Mars it is already automatically segregated. Everything will come automatically. Okay, so this is about Kistler, and then you have ForceTex. ForceTex also has a beautiful software, but the cost is it's not a lifetime software. Mars is a lifetime software. ForceTex जो है lifetime नहीं है, हर साल आपको पैसा देके उसको renew कराना पड़ेगा. But इसमें एक खास बात है, it will give you again instant results, comparison on the spot. Okay. Now, as I said, which one to use, how to select. So, if you are using for low impact studies, for example, gate and balance based studies, so up to 500 newtons vertical force is required. You can go up to 500 newtons vertical force. Whichever force plate provides you with this, you go for this. If your study is only gate and balance based. Now, suppose Now you increase the impact. Suppose you want to find out the takeoff and landing while jumping, then you have to increase the range up to 10,000 newtons. And then if you further go up to the impact, increase the impact, like for example in Olympic weightlifting, you go for higher range, 0 to 20,000 newtons. So what we have in our lab is Kistler force plate 9281 EA. It has a capacity of 15,000 newtons with an overload of 5,000 newtons. Overload is just a safety mechanism, just that it will tell you, okay, the force plate is loaded, you have to be careful. But 15,000 newtons is too, like, you cannot reach that. That is also a safe force plate until and unless you like deliberately throw very weighted product on that force plates. And these are sturdy also. And previously I mentioned the impact, whatever newtons you need, and this is about the sampling frequency, setting up of a sampling frequency. So for balance based study, you just need up to 100 hertz. That means 100 samples recorded per second. For walking, you can use up to 250 hertz. That means 250 samples recorded per second. But for high impact, okay, for a high impact, like jumping, running, landing, so more than 500 would be better, or maybe greater, more than 1,000 also, if you have. So this sampling frequency is just like your frame rate. I will just tell you, like using a very simple example. For example, I this is a force plate, and I have a ball which is bouncing. I am trying to bounce the ball on the force plate. Okay, so the ball will collide with the force plate, and it will go vertically up. ये ऊपर चला जाएगा. Okay, so if I'm using low frequency, suppose let's say 100 hertz. Okay, and if I say the impact of this force, the maximum impact is, let's say, 3,000 newtons. Okay, 3,000 newtons है इसका impact force, जो मैंने like पता कर लिया किसी तरह से. So if I use 100 hertz, there is every chance that I may miss this 3,000 newtons. I may get an impact force. मुझे ऐसा लगेगा कि मेरा जो मैक्सिमम इम्पैक्ट फोर्स है वो 2500 न्यूटन्स के करीब और 1000 न्यूटन्स के करीब ना, लेट्स से 1000. ओके, बिकॉज वो कैप्चर नहीं हुआ, बिकॉज टाइम फ्रेम इतना लाइक आपने कम यूज नहीं किया. ठीक है, 100 सैंपल्स पर सेकेंड एज कम्पेयर टू 1000 सैंपल्स पर सेकेंड. कुछ चीज आपने मिस कर दी, जस्ट लाइक द फ्रेम रेट विच वी डिस्कस्ड इन द प्रीवियस सेक्शन. Okay, so if I increase the frame rate up to 1000, then I am getting 1000 data points per second. That means there is a high probability that I will find out this. 3000 मुझे मिल जाएगा हाई इम्पैक्ट फोर्स. सो अगर मैं लो फ्रीक्वेंसी का यूज करता हूँ तो मुझे लगेगा कि 1000 या 1500 is the highest, because it will show like that. I may miss that. If I'm lucky, I can at that moment of time, if it is able to measure that, I may get that. But there's a high probability that I will miss that. So high impact forces, you increase the sampling frequency. Low impact forces like balance or walking, you can decrease, because if you increase the sampling rate, when you save the data, the volume of data is too large. बहुत ज़्यादा space occupy करेगा जो data है. Okay, so this is about sampling frequency, and yeah, this is again taken up from Kistler website. As you can see on the x-axis, you can see the frequency used for various ports. Okay, and on the y-axis, what is the impact force, what is the maximum capacity of this force plate. Okay, now one more thing I did not tell you, that this force plate, when you are looking for force plate, don't always think that you are only concerned with the vertical force. You need the anterior posterior, you need the medial lateral force. So a complete force plate will give you force in all the three directions. तीनों दिशाओं में force देगा. So always go for force plate which gives you force in three directions, because in balance based studies, you need a force plate which gives you forces in three directions, because based on that only the center of pressure displacement, center of pressure sway velocity is calculated, the sway range, the Romba quotient is calculated. I'm talking about the mediolateral and anterior-posterior force. And these are the forces which are basically responsible for finding out uh, if the player has mediolateral anterior-posterior stability or not by looking at the sway range, by doing some balance studies or dynamic balance studies also. अब dynamic balance studies भी आप कर सकते हैं. ठीक है. Now this is like using this you can actually see as the impact increases, the sampling rate increases. Okay, this is from Kistler website actually. So what are the practical applications? So you can assess the player, you can use it in strength and conditioning, you can use for technique analysis in combination with other tools like 3D motion capture, उसके साथ आप combine कर सकते हो. Okay, and you can combine it with camera also. Okay, strength and conditioning, like we all know that in strength and conditioning, if you devise a program, training program, it has a general preparatory period, it has a specific preparatory period, then the competition period. So let's say general preparatory period, you are basic for, you are actually going for anatomical adaptation. Okay, you can take the data as baseline, and after the GPP, if you want to start the strength phase, again you take the reading, and at the end of the strength phase, you again take the reading the force plate. So you can actually see where whoever is the coach कोई भी हो, you will see using the force plate data मेरे player का force बढ़ा है कि नहीं. If the player's force has increased or decreased, we will get to know whether my training is effective or not. We can actually see, and then after the strength phase, you can cover the power phase also. Plyometrics, जब आप plyometrics में जाएंगे, whether you can actually check where the particular height from where you can start the plyometric training, and we can actually find out the reactive strength index also during that phase. That means how quickly you are converting your eccentric to concentric, eccentric force to concentric uh, contraction. Okay, then you can assess the player for certain performance indicators. For example, with weightlifters, with jumpers, whether it is high jump, whether it is long jump or triple jump, we basically measure certain performance indicators like peak velocity, peak force, peak power per kg body weight, and then peak takeoff force as well as peak landing force also will measure. So apart from that, see, if you get a force time curve, you can actually calculate more than 30 parameters. The software Mars actually gives you more. But if you're working with a normal software like BioWare, like it will take for some time for you guys to analyze that. So, okay, so yeah, so we can do that. These are the practical applications, and then I will show you certain curves which can be generated and what is. I will start with the counter movement jump. This is the simplest test which is used to assess the explosive strength of a player. Okay, especially if I want to measure the explosive strength of a sprinter, of a long jumper. So I will ask the athlete to perform this kind of counter movement jump, and you can see this is a counter movement jump. This is a figure of counter movement jump. The athlete has placed his hands on the hips, and then he's going down, and from that position he's going up. So this is the typical force time curve which we get. This is the unweighing phase. This is the unweighing phase, and this is the peak force. You can find out the peak force. Now here you can actually differentiate between the eccentric contraction and concentric contraction by looking at the displacement curve as well as the velocity curve also. Velocity जहाँ पे zero है, तो वहां से आपका concentric phase start हो रहा है, मतलब negative. Velocity will be negative first, then at the point at which it is zero, then it will show you uh, the concentric part also. Then this phase is the time spent in air. So using this time, now this is accurately, force plate gives you this accurately. So using this also you can calculate the jump height using the formula gt square by 8. Now, Newton's laws of motions लगा के you can easily calculate that using Newton's laws of motion. And this peak, if you can see, this is a landing impact. So again, I can see the landing asymmetry also of a player. कि landing mechanics कैसा है. So usually if you have bad landing mechanics, you're landing on your heels, the impact force will be very high, है ना? But if you're landing on full foot or 4 foot to heel, you're going from 4 foot to heel, your impact force will be reduced, gravely reduced. Okay, so yeah, this can be used for testing. Now counter movement jump is the simplest step. Why? Because many of the movement, whether you run, whether you jump, whether you walk, even in weightlifting also, you have triple extension of your ankle, knee and hip joint. That is why this is similar to some other movements, and this basically gives you the performance indicators, whether the player is ready, what is the status of the player, you can find out. Okay, now this is one example. I will just explain which we had done some study with the volleyball player. So I have just taken uh, one one player's data. Okay, this is before and after the strength training, after the training phase. As you can see that now, this is the velocity curve. This is the velocity curve. This red one. Okay, this is the time of flight. Okay, so as you can see, I have compared the baseline level with the 8 weeks of training. As you can see, before and after the center of mass displacement, displacement from time of flight, everything has increased. The velocity also has increased 2.6. Earlier it was 2.4. The power also has increased 18 from 18 to 25. So we are also in process of developing norms for various disciplines. It will take some time because for now you need a huge amount of data, and you need this equipment also to be present in other centers. So as I said, like Sai will be receiving, we have force plate in other centers also, 1 or 2 centers. Now the force plate will be coming to 13 NCOEs, National Center for Excellence Centers. So that will greatly help us in creating the discipline wise norms. Also the norm also will depend on the phase of the training also. So as you can see the peak normalized force, takeoff force has also increased, the time of flight has also increased. This all indicative of the power. And this is the most important factor, time to peak force. That means कितना जल्दी force लगाया, कितना quickly force लगाया, कम समय में ज्यादा शक्ति. Okay, in minimum time you are creating or generating more force. That is also an important aspect which we can measure. That means we can measure the rate of force development, which is nothing but the slope of the force time curve. Slope of the force time. Okay, now yeah, this is a typical CMJ curve of a basketball player and a hockey player. So they have different movement strategies, as you can see from this figure. And this force plate actually can be used to find out the asymmetry between your lower extremities. यानी कि आपके राइट और लेफ्ट में कितना डिफरेंस है फोर्स में, आप फाइंड आउट कर सकते हो एसिमेट्री कितना है. सो नॉर्मली 15% asymmetry. As you can see, we have two force plates. So this is a force plate reading of one leg, and this is force plate reading of the other leg. Okay, so as you can see, uh, we can calculate the asymmetry using certain formulas. And if the asymmetry for normal population according to certain literature is 15%, okay, if the asymmetry is more than 15%, that means that athlete has a potential to get injured. वो इंजर हो सकता है. तो ये इन्फॉर्मेशन हमें जल्दी से जल्दी कोच को पास ऑन करनी होती. सो नॉर्मली दिस ऑल्सो टेल्स यू अबाउट the training also, or if the athlete is having certain injury. So we do a lot of testing actually, and some most of the time whenever we start the testing, we ask the athletes whether you are medically fit or not. They will bring their certificates also sometimes. Okay, we are fit also. We ask them whether you have any history of injury also. Initially they refuse, but when we perform their jump, and then when we ask them again, okay, showing this kind of a data, then they say yes sir, थोड़ा injury का issue है. So that means if their asymmetry is more than 15%, for athletic population, I would say that the asymmetry should be less than 15%, means less than 10%. 10% से भी कम होना चाहिए. So using certain strength and conditioning program, you have to take care of this asymmetry. Otherwise, your strong leg, your weak leg, both have the capacity to get injured if you have more asymmetry. Okay, so this is again, yeah, asymmetry curve. So you can actually do the squat analysis also on this force plate, and you can find out the difference again asymmetry between uh, right and left. But here is a catch. Uh, the player can control the squat actually because it's a slow movement, thoda full squat, body weight squat. But counter movement jump, because it is dynamic movement, the real character of that player will come out. Okay, it may, but this squat is good for uh, progressing, monitor the progress of the rehabilitation phase. Then we can do shoulder plyometrics also. So there are certain sports in which you need that extra shoulder strength also. So you can actually do the shoulder plyometrics. You can find out the power, and you can constantly monitor that throughout your training program. Then, yeah, this is the drop jump. You ask the player to jump from a certain height, and then you find out the reactive strength index. That means how quickly you are converting your elastic energy into your contractile energy. Sorry, contraction. Elastic energy. How much elastic energy is transferred to your muscle contraction? Okay. So here you can see this is the contact time, and this is the flight time. So using flight time, we calculate the jump height, and by using dividing jump height to the contact time, we'll get the reactive strength index. Should be more than one. For explosive sports, जो भी एक्सप्लोसिव स्पोर्ट्स है जैसे जंप हो गया, जैसे लॉन्ग जंप हो गया, ट्रिपल जंप इज देयर, okay, sprinting is there, their RSI should be more than one. Okay, so this all you can measure there, and this is for agility. So you can also perform lateral bounce here in on the force plate, and you can actually see the baseline level and after training level. Baseline mein what you will see that the player is having horizontal as well as vertical, but vertical is more than the horizontal. Vertical will always be more, but the ratio of that vertical power is less initially. But after certain amount of training, you will see that vertical force is also there, but your horizontal power has increased because now I am talking about the lateral. So it also tells you about the stability pattern of a player. As I said, force plate measures force in all the three directions. So we can make use of that facility. Then you can actually do the lunges, especially badminton players. है ना, lunge is a very important part. Lunge कर लिया, then recovery after the lunge, that is also important. So we can actually do some testing here, and you can find out the difference between right and left lunge. Okay, these are certain tests. And then of course you can do the balance studies. You can actually measure the force time curve, and based on that force time curve you can actually calculate the center of mass displacement, uh, center of mass sway area, sway velocity. Okay, medial lateral as well as anterior posterior sway you can find out. So yeah, this is a typical curve, walking curve. Okay, gait cycle. So do I have enough time, 5-10 minutes, or is there time for demo? I will try for a demo. If it's okay,
Sir, it's time for demo. We have 10 minutes, sir.
can I do the demo?
Yes, sir. Yes, sir.
Okay, okay, okay. So I will just stop sharing this. Okay. Okay. 1 second. Yes. So I will try to connect this. This. Okay. So is my screen visible here? Can you see?
Yes, sir. Yes, sir. We can see.
Yeah. Can you see the force plate here?
Yes, sir.
Okay. So view is visible. I will just open up the BioWare software. Okay. 1 second. Second. Okay. Can you see the interface of this software?
No, sir. Nothing. Just a second.
Can you see the interface of the software?
Yes, sir. Yes, sir. We can see it now.
Now, okay, okay. So as you can see, this is the length of the trial. This is a simple, typical overview of this software. And before performing any test, you actually ask the athlete to stand on the force plate, like I will be standing, although I am alone here. Right, right now, I will try to demonstrate it. So I will just weigh. Just try to. So I will just, as you can see, I'm standing on the force plate, and because there is only one person, I will try to. Okay. Yeah. So as you can see, can you see my weight now?
Yes, sir. It's 597.767.
Yeah. So my weight is recorded. So because I'm the only one, like this is just for demo. As you can see, we have two force plates, so I will be jumping on this only. So yeah, I will go for start here, and so I will just press OK. So I will just perform some movement because I am holding something, because I have to give command here. There also I don't have wireless. So as you can see, so the reading has started. I will just jump. Okay. So after this, yeah. Can you see the cover?
Yes, sir.
Okay. So I will just explain. Okay. So now based on this, because this is just a sample, so this is a freely available software. So yeah. So I am just interested in the FZ, that means the vertical force. I'm interested in vertical force, and because I've used only one force plate, I will select that, and then I will go to the show performance, and yes, then I will go to the velocity part, the displacement part, and then let me go to one by one. I will go one by one. Okay, we'll go one by one. This is the force. This is the force time curve. This is the typical force, and okay. So as you can see, this is my maximum force which I have exerted, 664 newtons. So using the cursor, I can find out at what time the maximum force, 4.5 seconds. Okay, so you can see, is it visible? Visible now? The cursor?
Yes, sir, it is, sir.
Okay, okay. So now this is my peak takeoff force, है ना? This is my peak takeoff force. Now the impact force is okay, 1975 newtons, because there was no effort. So ideally the impact force, whenever you jump, whenever you perform a counter movement jump, the impact force should be less than 5 times your body weight. More than 5 times, if you are performing, that means the same you are adhering to, in maybe mimicking the same pattern in your training also. So that is detrimental, that may be leading to potential injury also. Okay, and this is the time of flight. As you can see, this is, I'm using the cursor to find out a time of flight. This is my time of flight is 0.32 seconds, which is quite low. Obviously, I was just demonstrating. And then I will go to the velocity part. Okay, so I will change the unit so that you can see the velocity as well as the other curve simultaneously. Now, as you can see, this is my peak velocity. The peak velocity is 1.9. So for an athlete, if you ask me from my experience, if you are a sprinter, if you are a jumper, your velocity should be more than 2.8 meter per second. If it is more than 3, then I am talking about international level player. Okay, international level player, and we are because we are talking about performance indicators, we can relate the same with the performance of a 10 meter, 20 meter, 30 meter sprint also. उसके साथ भी हम जोड़ सकते हैं. ठीक है, this is the takeoff velocity. Peak velocity. Takeoff velocity is the velocity. This is the moment when you are about to leave the force plate, like ऐसे position में हो, you are in this position. So this, from this moment, this is wherever this coincides, this is your takeoff velocity. Now you can see my takeoff velocity is 1.62. Okay, and using the same velocity curve, actually you can find out the eccentric phase also. Now here the velocity is 0. So up to this phase, this is my eccentric force, and then concentric force. You can find out that also. But I will limit this to minimum only. Okay, so yeah, and then the displacement. I will go for displacement only. Again, I will change the unit. Now you can see this is the displacement curve. So what is my center of mass displacement? Yeah, center of mass displacement is 35 centimeters. Now, center of mass displacement, you should confuse with the jump height. Okay, center of mass displacement means, see, whenever I'm trying to jump, my center of mass has already displaced. By the time I'm about to take off, I am in this position. So my center of mass displacement has already has taken place. Okay, so we can use center of mass displacement. It will tell you about the flexibility of the player. We usually give center of mass displacement as well as displacement calculated from the time of flight. टाइम ऑफ फ्लाइट मेरा क्योंकि 0.32 है, तो एक्चुअली में मेरा जो जंप हाइट रहेगा इट विल बी 15 to 20 सेंटीमीटर से ज़्यादा नहीं रहेगा. Okay, if you calculate gt square by 8. So this is the thing which we can find out, and then we can actually give the power also. Yes, here this is the power curve just before the jump. What is my power? As you can see, uh, my power is 990 watts. Okay, so whenever we give or discuss power with athletes, we divide 990 watts with the body weight. So usually what we have experienced is power should be more than like 25 watts per kg body weight. Okay, that is, but again we are still developing norms regarding that. So yeah, this is a brief of counter movement jump, and many tests you can do. Okay, so I'm exiting this. So I'm ready for questions. Please ask question. Sorry, I've taken more time, but
No worries, sir. We are on time, sir, actually.
oh, that's that's fine, sir. Okay, so we can go to the
Okay, from
question.
the offline participants, do we have any questions? So there are some questions from the online participants.
Yeah.
Can we measure strength utilized or minimum energy expenditure
Can we
during
can we can you please repeat this question?
performance of particular asanas? Sir, am I audible, sir? Because your voice is lacking a bit.
I think I have to stop the screen share. Can I see the comments there itself? Have they typed? Uh, should I stop the screen share?
No worries. I can stop it from my side.
Okay, okay.
I can
So
stop from
because
my side, sir.
yeah, please stop because I can see the. I want to see the.
Are Kandagal, sir?
Hello. Yeah. I have joined back. Yeah. Am I audible?
Yes, you're audible, sir. And
Yes,
I have
we can.
flashed the.
Yeah. So
Can you see the
in
question,
that
sir?
whatever,
It's on the screen.
I can see the question. Yes, we can do that. We can actually measure the maximum strength, the average strength, the average force also, the power also, as well as the work done also. Okay, so using these metrics, you can find out during the performance of a particular asana. Of course, like we have a basic version of software, we'll get work done. Okay, there are certain other calculations which we can do. You can actually import this data into the excel. आप excel sheet में इसे transfer कर सकते हो data को. Then you can calculate other things also. But if you have a software like Mars which can calculate many parameters, बहुत parameters कर सकते
Thank you so much, sir. I hope Dr. Suryakant Patil is satisfied with the answer. There is one more question from him again. That's this one. In the screen.
if we want, yeah, we as I said, we can calculate the energy expenditure. And sir has asked for steadiness. That
Uh,
means
Steadiness
I am okay,
by
steadiness means
calculating energy expenditure as there is no
yeah,
movement in final position.
actually while doing yoga asanas we can actually check the sway, because the force platform will give you force in all the three directions using the vertical component and using the dynamic dimensions of the force plate. There is a calculation which by using which you can actually find out the center of pressure movement. Using that you can actually find out the sway area, कितना आपने medial lateral movement हुआ, कितने स्पीड से मूवमेंट हुआ, and how much for the total duration, how much energy is expended. Yes, you can do that. There is no movement, but if you measure on force plate, there you will find mediolateral uh, center of pressure sway. तो ये एक आप एक टेस्ट कर सकते हो, लाइक वेन एवर स्टूडेंट इज लर्निंग, okay, initially he might have more movement, so to see the progress of that player you can actually ask him to perform that asana or perform that movement on the force plate, and by the time he actually practices and gets like let's comfortable with that particular movement, he's is so you can see that the sway area, sway velocity, mediolateral sway, as well as the anterior posterior sway has all decreased. So if you do a yoga asana on force plate, even if you're saying that there is no movement, you will actually find some sway. And if the sway is minimum, that is good only.
Thank you so much, sir. There is one more question from Ankur Pukhon. I'll just show his question.
Uh, I will just clarify, 2.8 meter per second is the vertical component which I was talking about, and it is for our experience that whoever sprinters we have measured in the initial stages, they start from 2.6, and based on their training, based on their strength phase, based on their power phase, plyometric phase, especially in the plyometric phase, we again reassess the player. So it depends on the training, it depends on the coach. Plyometrics, we are now talking about the plyometrics. We are actually talking about because if you are talking about the sprinter, we are talking about the hot capability of that player to generate the horizontal reaction force, because that is the force which pushes you in the forward direction. Vertical ground reaction force will always be there. So there is a ratio of horizontal force to the total ground reaction force. So if you are able to calculate that, so using, and if you are able to calculate the force velocity profile, you will get to know whether the player has to work on force or whether the player has to work on the velocity. If the player is lacking in force, you go for the force part. If the player is lacking in velocity, you go for the velocity based training. In that way, so some of the sprinters, national level sprinters, I have seen that they cross 3 meter per second in the counter movement jump test, which is actually quite rare in my life. Like the whole like working period in Sai, I might have seen that only 15 to 20 players. I'm talking about jumpers, I'm talking about sprinters, I'm talking about the triple jumpers also, even weightlifters also. So I've seen only 15 to 20 this year, but I've seen many players crossing the three. So three is just a performance indicator. It tells you that player is in very good conditions. Okay, but how the player translates into the field, that we have to monitor that also. The plyometric, the power phase, velocity based, no? Yes, these plates can be used in archery. Actually, we have used this force plate for shooter, 10 meter shooter also, because in archery, again, the balance is the important part which we need to measure. So right from the start of the position, assuming position, okay, and the release, and coupled with the heart rate भी मॉनिटर कर सकते हो आप. सो ये काफ़ी लाभदायक होगा, दिस विल बी वेरी हेल्पफुल. बट अगेन इसके लिए आपको बड़ा, लाइक यू डोंट नीड हाई कैपेसिटी फोर्स प्लेट्स. You can go for minimum 5,000 liters force plate with minimum sampling rate 100 to 250 sampling rate, that is enough for you. So force plate, according to your use, you have to choose.
Thank you
So
so much,
yes,
sir.
yes, yes, please.
Yeah. Thank you so much, everyone, for nice questions and who is joining offline and online mode as well. I, on the behalf of organizing committee, I would like to thank you, sir, for doing the presentation and also giving a short demo of force plate. It has been a splendid presentation, sir, from your side. Guys, this is Dr. Praveen Nair, and one of the great biomechanists, and we are getting. It's an honor to be have, sir. Thank you so much once again.
Thank you, sir. Thank you for sir for your generous introduction, and I'm honored actually uh, to speak in on this platform. Thank you very much. I hope I can contribute more towards the learning phase. Thank you. Thank you very much.
Thank you so much, sir. With the permission of the organizing secretary and the workshop director, I would like to announce that this session has concluded. We will meet for the third session, which is of Dr. Ikram Hussain from Aligarh Muslim University, which will start at 3 o'clock sharp. Thank you so much. Thank you so much, sir.
Thank you. Thank you so much. Thank you.
Hello, Ikram sir. Good afternoon, sir. Hello, Ikram sir. Can you hear me, sir? Good afternoon, sir. टेस्ट 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 मैं ये देख रहा था कि मेरा आवाज मेरा मतलब मेरा आवाज कम नहीं है, मैं अपनी तरफ से पूरा ये विक्रम सर का